Okay, so this is 2022 paper 2 question 1. The table below shows some details of different types of student in a university. There are 2,714 students in the university in total. Okay, so the first part of this is pretty straightforward. We're just going to get a total for 23 or younger. So 12,785 adding on to 1,353. So I'm getting 14138. Then I am doing, in the next one, I'm missing the postgrad section. So I'm going to do the total 8,576 minus 2922. And that gives me 5654. And then finally 22714. And I take away the 15,707. And that leaves me with 7,007. And of course, I mean, it should add correctly this way. And it obviously should add correctly this way. So you can kind of double check your figures. Okay, so that's that one done. One student is picked at random from the students in the university. Let O be the event that the student is 24 years old or older. And let U be the event that the student is an undergraduate. Are the events O and U independent? Now, any mention of independent, we've come across this before, then the probability of O intersection U should be the probability of O multiplied by the probability of U, if they are independent. So if this sentence works, they're independent. If it doesn't, they're not independent. Okay, so O intersection U. So we're basically looking for students. So students who are both 24 years old or older and undergraduate. So there's 2922. So 2,920 students that are both, because intersection is going to have to be both, that are both 24 years old or older and who are undergraduate students. Now that's out of the total, so we better put it out of 22714. Right, on the, actually we might work that out first. So 2922 divided by 22714. So that's coming out to be 0.1286 to round it to 4 decimal places. Okay, so what's the probability of a student who's 24 years old or older? Now this is obviously with no restriction. So the total for my 24 years and older is 8576 over the total, 22714. And then what is my chances that the student is an undergraduate? Now that's in total. So my undergraduate one is here. So that's my total for undergraduate, 15707, all over again, the total number of students in the university. So I'm going to multiply the two of these together and see if it gives us the same probability as the intersection. Okay. So this is 0.37756, blah, blah, blah. I'm now going to do the other one. 15707 divided by 22714. 714. So that's giving me 0.6915, etc. And now I'm going to multiply those together and see if it gives me the same as the left-hand side. Now, it doesn't give me the same, so I end up getting 0.2611 if I do 2 decimal places. They are not equal, so they are not independent of each other. Okay, they're not independent of each other. Okay, the next one, 3 people are picked at random from a class. Find the probability that all 3 were born on the same day of the week. Assume that the probability of being born on each day is the same. Okay, so I'm going to draw 3 boxes here. So I'm going to think first of all is what is the probability of being born, of 3 people being born on any day of the week? So the first person would have a choice of 7 days, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. If there were no restrictions, the second person would have 7 choices, and the third person would have 7 choices as well. Now, so our total here, if there were no restrictions, would be 343 ways. Now, in this case, there are restrictions. The first person, in essence, can be born on any day of the week, so they'd still have their 7 choices. But if they are all to be born on the same day, then there's only one choice left for each of the remaining 2 people, because if the first guy, for example, was born on a Tuesday, well, then the second guy would have to be born on a Tuesday. So he couldn't pick, so to speak, any other day bar Tuesday. So 7 by 1 by 1 is 7. So there's 7 over 343 what the probability, I should say, is 7 over 343. So there's a 1 in 49 chance that in this class, 3 of the students are going to be born on the same day of the week. Okay, part C, there are boys and girls in a class where B and G are elements of N. Now, if it's number of boys and girls, well, obviously it has to be a natural number, because the smallest number of boys I could have would be no boys. I couldn't have a negative. So 3/5 of the students in the class are girls. Okay, so straight away, what do I know? Well, I know that the girls out of the total, which would be boys plus girls, is 3/5. That's a 3, so it will be 3B plus 3G. Okay, so yeah, so that's kind of all I know for the moment. It says 4 boys and 4 girls join the class. One student is then picked at random from the whole class. The probability that the student is a girl is now 4 over 7. Okay, so all of a sudden now we're going to have 4 extra girls, and our total is also going to increase. Well, it's going to increase by 8, because we now have 4 girls and 4 boys. And the answer this time is supposed to be 4/7. So again, I guess I need to cross multiply here. 7G plus 4G plus 32. Now, because we're missing B and G, I immediately suspect that this is going to be simultaneous anyway. So I'm going to tidy each side up first of all. So I'm going to bring the 3 over here. So that's 2G minus 3B equals 0, because there's no other number there. On this side, I have 4B. So that would be minus 4B if I bring him over. If I bring the 4G over, it's going to be 7G minus 4G, which is 3G. And then I have 32 minus 28. So 28, 29, 30, 31, 32, that's 4. So these, I should be able to set these up, just putting them together, and then I should be able to get my answer. Oh, where did I get B? B for, oh yeah, sorry, sure. Sorry, I just need to put them underneath each other. I just need to line up the correct letters. So I'm going to put the minus 3B under there, and I'm going to put the 2G there. Now I need them to, so I need to get them to match, but have opposite sign. So I need to get them to match, but have opposite signs. So I'll have to go for a minus 3 on the bottom. So that'll change that to plus 9B minus 6G, and then 0. They cancel, and I'm left with 1B is equal to 8. So that would suggest there are 8 boys. And then what I would need to do then is go back and find the girls. So 2 girls minus 3B is equal to 0. So 2G minus 24 equals 0. 2G is 24. G is 12. So there are 12 girls and 8 boys.